In this video, we're going to go over the Waveform tab of the Analysis Editor. The Analysis Editor has 8 different tabs: Waveform, Curves, Distortion, Delay, Time, Frequency, Loose Particles, and Electrical. Many of these tabs change depending on what algorithm you're using. However, Waveforms, Curves, Delay, Loose Particles, and Time Envelope are available in every algorithm and are the same throughout. We'll take a look at those tabs first, and then save the other ones for when we discuss the specific algorithms that use them. Let's look at the Waveform tab in the context of a sequence. Say I want to test the frequency response and impedance of a speaker. I have an amplifier and a reference mic connected, so let's write a quick sequence. I'll choose a sweep as my stimulus. For acquisition, we need a play and record step to actually play that. I'll choose reference mic and impedance box for the inputs, and for the output, I'll choose the same amp channel 1 that I chose for the stimulus. Now we'll pick an analysis step. I'll choose the fundamental template. When I double-click on this step, it will open up the Analysis Editor. At the top, you can see the algorithm is heterodyne, and we're on the Waveform tab. The first choice we can make here is if we want an absolute or relative measurement. Absolute response is the response level only and is stimulus dependent. For example, if we change the stimulus from 1 volt to 2 volts, there will be a 6 dB level increase. Relative response is the response level divided by the stimulus. If we increase the input level, the relative response will not change if the system is linear, because the output level will increase by the same amount as we increase the stimulus level. There are 2 other sections here: the stimulus and the response. In the stimulus dropdown, we can see all waveforms in the sequence. The sweep is our stimulus, then the 2 recorded time waveforms on our reference mic and impedance box channels. In the stimulus box, we want to choose our stimulus, so sweep is correct. When we have sweep selected, SoundCheck will look at the type out and the output signal path used. It correctly recognizes our sweep as a frequency step sweep and the output signal path as amp channel 1. This isn't adjustable in the analysis step. It's just reading from the stimulus step. This checkbox will apply correction out. This is dependent on having a calibrated output channel. Response is the same options as the stimulus. This dropdown will let us select our waveform. But in this step, we're going to want to analyze the fundamental, not the impedance. So instead of selecting in the impedance box recorded time waveform, we'll select our reference mic recorded time waveform. You can see the input signal path will update from impedance box to reference mic. We also have the option to apply correction in, which again is dependent on having a calibrated reference mic input. Let's run the sequence and take a look at some of these options on an actual frequency response. So with the current settings in my analysis step, here's the fundamental of my speaker. One nice thing about the stimulus, acquisition, and analysis steps, split into 3 discrete steps, is we can actually go in and make changes to the analysis step and apply them without needing to play and record out of our DUT again. So if I go in here and make any changes, all I need to do is hit apply, and you'll see it updated on our curve. On the current graph, the y-axis units are dB RE 1 Pascal per volt. This uses the output signal path of the stimulus, the amplifier, which is in voltage, compared to the input signal path, the reference mic, which is in pascals. If we switch it to absolute, it will only care about the input signal path. We hit apply, and the units change to dB SPL. We'll switch back here and notice the shape of the response doesn't change, just the units that it's measured in. I am using a calibrated output and input signal path, so let's see the difference when we apply the correction. The output signal path is an amplifier, which is very flat, so the correction should do very little. It's almost unnoticeable, but around 5K you can see a little bit of change for the correction of our amplifier response. The correction in is a little bit more noticeable, but still isn't much. My reference microphone is pretty flat, we're just going to correct for a little bit at the high and low ends. For more information on calibration, we have an earlier video that goes into how to calibrate your input and output devices, and where this correction will actually come from.